Let us begin a new chapter, Effects of Electric Current. We have to study now a small topic, that is energy transfer. Before starting energy transfer, we will study or we will revise few equations which you had studied in standard 9th. First equation, that is V is equal to W upon Q. Therefore, W is equal to V into Q. Now the second equation, R is equal to V upon I. Therefore, I is equal to V upon R. The third equation, I is equal to Q upon T. Here, therefore, Q is equal to IT. The fourth equation, that is P is equal to W upon T. Now, here we people already studied these equations. Now, first V is equal to W upon Q. V means a potential difference. Now, how we can be able to study, or we will see now what is potential difference. So, for that, first I am drawing one circuit diagram. Here, positive terminal as well as negative terminal of the cell. Here the key, then here I am making the bulb. Now, as and when switch on this circuit, current flow will take place from positive terminal to the negative terminal. As a result of it, you can find that bulb begins to glow. Here now, at the same time, electrons flow from negative terminal to the positive terminal. So, here we can say that positive charge flow from positive terminal to the negative terminal. At the same time, negative charge flow from negative terminal to the positive terminal. As a result of it, you can find that here bulb glows. So, at first, negative charge flow from negative terminal to the positive terminal. As a result of it, positive charge flow from positive terminal to negative terminal. So we can say that here positive charge flow is taking place, that time current flow is taking place. Now we are studying about the potential difference. This potential difference is creating by the cell, what we are connecting here. Now here positive terminal is having high potential and negative terminal has low potential. So here high potential, which one has? Positive charge has, or positive terminal has high potential. Negative terminal has low potential. We can say that the difference between high potential as well as low potential, high potential as well as low potential, that is known as potential difference. So we can say that what is potential difference? Difference between high potential as well as low potential. So we can say that we had already studied before. That means from water always falls from higher level to, or flow from higher level to lower level. Similarly, current flow also will be taking place from higher level to the lower level. So the difference between this is lower level, this is higher level, the difference between them, that is known as a potential difference. Now potential difference want to measure, for that one instrument we are using, that instrument is known as voltmeter. Now here V is equal to work done, amount of work done upon charge transfer or transfer of charge. So potential difference is equal to amount of work done to flow charge from one terminal to the other terminal. So we can say that here V is equal to W upon Q. W means amount of work done to flow charge from one terminal to the other terminal. So that particular time how much charge is flowing. So we can say that for flowing this charge, how much work is done by this cell. So that is known as V. V is equal to W upon Q. Now from this equation, work done we can find out. For finding the work done, we have to multiply potential difference. V means potential difference with charge. Now here other equation, that is R. R means resistance. Now for studying about the resistance, I am showing you one diagram. This is a conductor. This is enlarged view of the conductor. Here now, this, the whole thing we can say conductor, wire. But this part enlarged condition I made now. So in this we can say that number of atoms will be there. That means each and every substance made with the help of atoms. Middle you can find that electrons. This is a conductor. So middle you can see that electrons. We are studying about resistance now. Resistance or resistance of the conductor. So here these big circles I made, they are the electrons, small dots, that is the atoms I made. Now as and when we allow the current to flow through this circuit, because here again I am making key, switch connection. Now here we can say current flow is taking place. So as and when current flow will take place through this circuit, you can find that electrons flow from negative terminal to the positive terminal. So here we can say the electrons are there, they flow from negative terminal to the positive terminal. So here you see, in this case the flow of current is taking place. At the same time here you can find that electrons flow is taking place. Now these electrons start to flow from negative terminal to the positive terminal. Now such a way you can find that the flow of electrons will take place from negative terminal to the positive terminal. As and when electrons flow, middle means you can find that there are number of atoms. When they move, they hit, they collide on the atoms. As a result of it, their speed reduces. That means they go or they fall backward. As a result of it, again they start to move from negative terminal to the positive terminal. So as and when they move from negative terminal to the positive terminal, middle they face hindrance. Hindrance, H-I-N-D-R-A-N-C-E. They face a hindrance, we can say. Hindrance means some obstructions or some obstacles are coming middle. We can say that these atoms I said you, these all atoms are stationary. These atoms are stationary. As and when electrons move, they go and hit on them. As a result of it, again their speed reduces, they go backward. Then again they come. So how much more and more hindrance is occurring, or more and more hitting is occurring, collisions are occurring. As a result of it, we can say that more collisions are there, we can say that there more resistance is there. More hindrance or more obstacles, then we can say that more resistance is occurring. If more resistance is there, then there will be the flow of less current. If less resistance will be there, more flow of current will be there. More resistance will be there, less flow of current. So we can write here like this. More resistance, then we can say less current will flow. Now, less resistance will be there. If there is less resistance, that means electrons does not face more collisions on its way, then we can say that there will be less resistance. If there is less resistance, we can say that there will be more flow of current will be there. Then there will be more current flow. So here electrons moving from left to right, or we can say that here negative terminal, this is negative terminal to the positive terminal. So when it moves from here till here, this all places movement is there, but I shown only a small part in enlarged condition, big size I shown. Now that time, as and when it moves, where all atoms are there with them, if it hit, then again the movement of the electron opposite side, it will be towards the opposite side. That means once it go and hit, immediately it move backward. Again it takes its speed, again it coming to the positive side. So there middle such obstacle will be there. Then the flow of electrons will be backward direction. Then again it collects, then it moves. So here we can say that how much more and more obstacle will be there, that much resistance will be there. That means the resistance means opposite, or we can say flow of current stops or prevents the flow of current. How much more and more electrons move, that much more and more current flow will be there. But here middle such a hindrance is there, because of that current flow reduces. So how much more current flow reduces, that much more resistance will be there to the conductor. Now here this is the resistance. So more resistance means more hindrance is occurring on the way of electrons. Now here formula for resistance V upon I. Again from this we can find the formula of I is equal to V upon R. Now again here I, for finding I, one more formula we are having, that is Q upon T. Q means charge, transfer of charge we can say, or movement of charge from one end to the other end. Now upon time, so amount of charge moving from one end to other end within a particular or within a unit time, that is known as I. I is equal to Q upon T. We can say Q means amount of charge, transfer or move from one terminal to other terminal within the unit time. Now from this again we can study one more equation, that is Q is equal to I into T. I means current into T. T means time. Now other equation, that is P is equal to W upon T. Now P means power. Now how we can be able to find out power? Suppose if we want to climb staircases, now we can say that if we move from ground floor to second floor, we can move either by using lift or by walking or by running. So three methods we can use it for climbing up from ground floor to second floor. Now here if we are walking, time requirement will be more. if we are if we are running, time requirement will be less. Now, if we are using lift, we can say that time requirement will be very less. So here, for finding power, what is the formula here? W upon time. That means work done within a particular time. Work done for doing a particular work, or work done within less time or more time. So here we can say that work done with less time. So we can say that here power more. P more. P means power more. Here we can say that work done, that is within less time, because of that power taken or power of us will be less, or power exerted by us will be less. Now here, by walking we climbed from ground floor to second floor. So for that time taken more, so we can say that power exerted by us is least. Very less, least, or we can say very less power we had taken, or we exerted very less power. So here now, for finding power, we are having one formula with us, that is W upon T. W means work done upon time. So for detecting the power of a particular person, now we can say a small baby, means a boy is there, means a 10-year boy. So he won't walk and climb, mostly he will run and climb. At the same time, very old person climbing staircases, then he will take more time. So when we compare a boy, 10-year boy, as well as an old person. Now, when we compare climbing on staircases, we can see that 10-year boy will run and climb, at the same time old person will walk and climb. Then whose power will be more? Power of the boy will be more. Why? Because both of them are doing same work, but this boy is taking less time, at the same time old person is taking more time. So we can say that power of the boy is more than power of the old person. Now we will study about energy transfer. Now, for studying energy transfer, with the help of a diagram we will study. One circuit diagram I am drawing. Here I am connecting one coil. This is known as a resistor, or we can call it as resistance. Both of them one and the same. Now, resistance, its name A as well as B. Now, from this resistance, I am connecting one voltmeter. When we connect the voltmeter, we have to concentrate that voltmeter always connected to the resistor parallelly. This and this parallel connection. Now here I am connecting one ammeter. This ammeter I am connecting serially after resistor. That means one after other connection. So we can say this is the serial connection. That means a series connection. Serial, not series connection. This is known as a parallel connection. Now here I am connecting one cell. Small line for negative terminal, big line for positive terminal. Now here the current flow is taking place. Now here one key connection also we can connect in series. Now you can see that current flow will be from positive terminal to the negative terminal. Now here, as and when current reaches here, it flow towards here, it flow towards here. Once it is coming from here, then it is going through here, it is going through here. So we can say that this is the positive terminal of the voltmeter, this is the negative terminal. You see now, current flow from positive terminal to the negative terminal. So we can say that through here as well as through here its flow is there. Current flow, this way it is coming. So here positive sign, here negative sign, again it is going through here, again we can say it is flowing through here also. So current flow is taking and reaching here, so we can write here this is the positive terminal, this is the negative terminal of the ammeter. So this is known as ammeter. This is known as voltmeter. This is known as cell connection. This is the key. Now this is the resistor. Now in this experiment what we people are studying. So that is here as and when the charge flow from positive terminal to the negative terminal, we can say that current flow from positive terminal to the negative terminal is taking place. As and when it reaches here, the coil started to get heated. Now here we can say that this resistor is getting heated here. So we can say that as and when we start to flow current through this conductor or through this circuit, we can say that energy flow is taking place. So we can say that flowing, which energy is flowing? Electrical energy is flowing from here till here. Once it reaches here, this electrical energy passes through the coil of the wire. Now we can say that this coil of the wire we can say as a resistor. Once it passes through here, we can say that there will be the production of heat energy. So here we can say work done for passing current through this conductor to here, that transforms to heat energy when it passes through this resistor. So here work, how much work is doing for transferring or for passing current from one end to the other end. Meanwhile here we can see the resistor. Once it passes through the resistor, we can say that heat energy is producing. So one form of energy converted to other form of energy here. Now the same thing we are studying. Now we can say that how much energy flow is taking place, that is transformed. So here work done to transfer electrical energy to heat energy. So both will be how much work done. The same work done will be equal to how much heat energy is produced. So we can say that W, that means the work done, will be equal to heat energy produced in this resistor. Now that thing we have to prove it. For that we are having one formula with us. Heat energy is equal to I square RT. Now we people have one formula with us, same formula. That is V is equal to W upon Q. Therefore W is equal to VQ. Now here V is equal to, now V is equal to one formula we can write. Here again I am writing one formula. V is equal to IR. V is equal to IR. From the same I derived. Here R is equal to V upon I. Again I is equal to V upon R. Again now V is equal to IR. Now this formula I am substituting here. So W is equal to IR then into Q, you people already studied here. Q is equal to I into T. Now we will write as W is equal to I into I square R T. Here we studied H is equal to I square RT. Now same equation we have got here. W is equal to I square RT. So therefore we can write H is equal to W. W is equal to I square RT. Now this I square RT is known as Joule's law equation. I square RT is known as Joule's law equation. Now we will study what is meant by Joule's law equation. Joule's law equation states that heat produced in a conductor is directly proportional, or heat produced or heat generated in a circuit is directly proportional to the square of the current, resistance of the conductor, and time through which current flows through the conductor. Now we will study different units, that means SI unit of different components or different measures. Now SI units we are studying. Now SI unit, its full form is System International. System International. Now first we people will study here P is equal to VI. P is equal to VI. Now here P, that means the power generated by a device. For finding that potential difference multiplied with the current flow, how much current is flowing, that we have to multiply. Now the unit of power we have to derive. So for that V means a volt, potential difference, volt. So we can say that 1 joule per 1 coulomb. V means 1 joule per 1 coulomb. COULOMB. C means coulomb. J means joule. So here now V, that means 1 joule per 1 coulomb multiplied by 1 coulomb per 1 second. C means a coulomb, S means a second. Now here again I am writing P. P is equal to V into I. V means 1 joule per 1 coulomb into 1 coulomb upon 1 second. Now what I am doing, this coulomb and this coulomb cancelling. So what we will get, 1 joule per 1 second. Now so here I am writing, therefore P is equal to 1 joule per 1 second, or we can call it as W, or we can call it as watt. So unit of power is watt, W-A-T-T, watt, or we can write here W. P is equal to, in numericals the unit we have to mention, so unit of power is W, or we can say as watt. Now we have to write other units, that is I, I means current. I am writing here current. Its symbol is capital I. Its unit is capital A. This is again SI unit of current is ampere. A means ampere. A-M-P-E-R-E. Now second one, that is, I am writing here potential difference. I am writing potential difference. PD means a potential difference. Its symbol is V. Again it's a unit also V. V means a volt. Now the other thing, that is Q. Q means a charge. I am writing charge. In bracket I am writing Q, that is the symbol. So here I am writing capital C. Capital C means a coulomb. C. Capital C, that is a coulomb. I am writing little close by here. So that is a C. That means a coulomb. Now we can say that other one, length. Length or distance we can say. So that is L. Its SI unit is meter. So symbol is capital M. MET unit R. Meter. Now next one, that is time. Small t, that is a small s, that means a second. Now the another one, work, that is W. Its unit is J, that means a joule. Now we can say that resistance. Resistance, capital R, that is its unit is ohm. This is the symbolic representation. Spelling is capital small o hm or capital H O hm, no problem. Ohm. Ohm it is. Then now here resistivity. Resistivity. Its symbol is rho. RHO. That is ohm meter. Now here resistivity formula or resistivity equation. Rho, that is equal to capital R into area upon length of the conductor. So here we can say R means ohm I written, afterwards into area means length into breadth, both of them in meter, upon here length in meter. This meter and this meter cancel, we will get ohm meter. This is the derivation of this unit. Now power P, that is equal to capital W, that is only watt, W-A-T-T. Now, so these are the various SI units of different values. Now we will study about heating effect of electric current. It's a few examples. Now, heating effect of electric current. Its meaning. With the help of its applications we are studying. As and when we pass current through the conductor, heat is producing in the device. As a result of it, our work is done. There are some examples. We can say that electric bulb. Second thing, electric iron. Third thing, we can say electric heater. Then electric water boiler. Then we can say electric cooker. Then we can say fuse. These all are the, again we can say that there are some coils. Heating coils are using people, or this much enough to us now. There are different coils also there. We can say now this many examples enough. So electric bulb, electric iron, electric heater, electric water boiler, electric cooker, as well as a fuse wire. Bulb I am showing to you. This is the bulb. Here you can see that it has terminals. Again here the connection is there. Again its inside you can find that there will be a coil. Here you can find like that. Now we can see that here. Now afterwards I am making like that way. Now here again its connection will be, one rod will be there. Again we can say that from here coils will be there, coil will be there. We can say that here again its connection will be there like that way. Here again from here also support will be there. Now we can say this coil is made with here again wire connection will be there. We can say that this coil is made with the help of tungsten wire. Tungsten wire, its melting point is there, that is 3400 degree Celsius. So as and when we flow current through it, we can find that this wire or this coil is getting heated. At the same time, it does not melt. Because of the heat producing inside, there will be the transfer of heat to light. As a result of it, we are getting light when we glow a bulb. Now, here we can say that in this case, here there is a vacuum situation is there. That means there we won't have any oxygen. But here either nitrogen gas or argon, that means a noble gas it is. Argon gas they are filling inside. As a result of it, when a bulb break or bursts, you will hear a sound from it because that gas want to come out. So we are hearing the sound. So here we can say that a coil of wire is there. This coil of wire is present in the bulb, that is tungsten wire. It needs such a large temperature or high temperature for melting. So as and when current flow through this coil, this much current or this much heat is not producing. This much as and when current is flowing through this bulb, this much heat is not producing. For melting this much current is required. So as and when heat is getting into this coil, we can say that that much heat production is occurring. So as a result of it, the heat how much is producing, that burns or burning Sine we will be, or red colored light is producing when current is flowing through this coil. So we people are getting the light when current flowing through this bulb. Now we people are studying about electric iron. Here I am showing you an electric iron. This is the surface part of the electric iron. When we open this, it's inside. You can find that here in case of this thing, such a way coil connection is there. Such a way coil connection is there. Now this coil is connecting with the wire connection. Now here we can say this coil is covered with the help of a sheet, I can say. That sheet is known as, that means protecting from upside as well as downside. This is the outside cover. This is a metallic cover. It is a metal. Now this is again a metallic cover only. This is the handle, and we can say this is the wire connection is there. Now this cover and this plate is there. It's inside, but attaching to the bottom part, you can find that such a coil connection on that coil as well as its bottom side, up and down of this coil, one plastic coating will be there. Plastic, it is not a plastic. I am saying you plastic, like one cover will be there. That is known as mica sheet. Mica sheet. Now, what is the advantage of using such a mica sheet? Now, mica sheet's speciality, it does not allow current to flow through it, but at the same time it allows heat to flow through it. Because of that, we can be able to iron our clothes. So we can say this is again heating effect of electric current. That means it is an application. Iron is an application. With the help of that, we are able to, that means heating effect of electric current means with the help of heating effect of electric current, which all help we are getting, which all work we can be able to do. So here heating effect of electric current, bulb glows. Here heating effect of electric current, we are able to iron our clothes. Plus, because of this mica sheets coating up and down part, we are not getting any shock by mistake if we are touching on the surface of the or bottom part of the iron while ironing. By mistake if we are touching on this, then also we are not getting shock. Why? Because the mica sheet protects us from the electric shock. Why? Because it is only allowing the heat to flow, but it does not allow the current to flow. Now, other example, that is water boiler. This is known as a water boiler. Here base is there, as well as here its base is there. Now here some positive as well as negative terminals are there, and this one also having positive negative terminals, and we can say wire connection is there. Now here I am saying you inside of this coil is there. That is also, I think, means around flat condition coil will be there. That coil, as and when we flow current through it, the coil is getting heated. That coil is allowing the water, how much we are filling inside, to getting heated. So this is known as a water boiler. This is working with the help of electric current. Now again we can say other thing, even we can say that electric water boiler, I said electric heater you might be seen. That means normally people are using heater. That means in our in a container, any container, steel container and all, people are inserting and keeping like that way one coil. You might be seen that thing. Then this is having connection with the electricity. So this, how much water you people are pouring and keeping in this container, that is getting heated as and when this coil is getting heated. So this is known as electric heater. This is normally people are using it, but it is highly risky. Why? Because if you are keeping this container as well as this heater, if you are inserting and keeping, by mistake if you are touching in the water or hand, sometimes a shock getting chance is there if it is not having such a insulation. Insulation means a protective cover is not there. Sometimes it's a protective cover gone. Such a case all will be there. That means if it is non-insulated, protective cover is not there, then there is a chance for getting shock to us. Now other device is there, that means coils are connecting and keeping. Such a way, like that a coil is connecting and keeping there, such a way coil will be there. We can say that people are using it as electric stove. Such a coil will be there. Electric stove like people are using it, then that is on that we are keeping the utensils for cooking our food materials. Our food material is getting cooked. Now that means such a coil people are using it. Then for that such a device all will be there. Then here switch system will be there. Like that some system all is there. Then here handle all will be for keeping our container, some gas stove how it is there, same way such a a burner system all will be there. This thing, as and when we pass current through it, this coil will get heated. So more turnings are there, more coil is there, so more heat is generating. As a result of it, we are we can be able to cook our food materials. Now electric cooker is there. Cooker, how our normal cooker is there, such a way. But in that also, as I shown you that a water boiler, such a this coils arrangement will be there. Then we can be able to use electricity for cooking food materials by using such a type of a cooker. That is also nowadays available. Now last topic, that is a fuse. Normally in all the houses fuse connection will be there. This fuse connection, normally here in Mumbai we are not having its used so much, but at the same time in villages, if high voltage, sometimes high voltage of current flow is taking place, sometimes a low voltage of current taking place. So if more voltage of current is flowing, the fuse wire is there. There is one fuse wire inside the fuse switch, I can see. Now this fuse wire mostly made with the help of lead. Similarly, other type of metals which are having very low melting point, such a type of metals using wire they are fixing and keeping in the fuse switch. Now we can say that as and when current high voltage of current is flowing through such fuse wire, immediately this fuse wire getting melted. More current flow will be there, such a fuse wire is getting melted. As a result of it, now suppose if there is connection with we can say fridge, TV, AC, such a device, if it is there in our home, more voltage of current is flowing, then what will happen? This fuse wire will get melted. As a result of it, current flow towards these all instruments or devices won't take place. Why? Because all current flow, which all devices are present in our home, its all connection through this fuse wire is happening. Once a fuse wire is getting melted, current flow stop here. Once current flow stop here, these all devices will stop working. But at the same time, they are getting protection from current, or we can say from destroying, we can say. Otherwise, high voltage of current, some limited current only should be flow through all these devices. But beyond that, if any current is flowing through it, these devices will spoil. So for protecting such all devices from high voltage, we are having such a connection that is known as a fuse wire connection. As a result of it, our instruments or devices are getting protected. Now last two topics more, that is One thing we can say overloading, other one short circuiting. Now here, what is overloading? Overloading. Now, in our home, just imagine in our home, iron box, TV, fridge, AC. So, such a devices are there. Just imagine like that way many more, even we can say oven, etc. Like that way many more devices are there. Now, at a time, if we are working all these devices, then more and more current requirement is taking place for working all these devices at the same time. So as a result of it, it will be a burden to our transformer. We can say that transformer means a meter box. There means some limited flow of current only should take place. We can say that 220 voltage of current only should be flown or should be used. But beyond that, at a time if you are using, then our device will be getting spoiled. So for protecting all these devices from overloading, limited number of devices we have to work at the same time. So this is known as overloading. Now we are studying about short circuiting. This is again a simple topic. Short circuiting. Now what is short circuiting? We can say that normally in villages, again I am saying you in villages or here also it is possible. That means there are three types of wires. One wire we can say live wire, neutral wire, then we can say earthing wire or earth wire. These three wires connection is there towards each and every devices which are there in our home. Now sometimes what is happening, this live wire as well as neutral wire, if they are coming close by, just imagine both of them are coming close by. At the same time, its protective cover, that means we can say insulation gone. Just imagine, here from here insulation gone, from here insulation gone. So we can say that both of them are having nearby area bare condition, bare wire is there. That means insulation is not there. So what will happen? Both of them are having the capacity to produce high temperature. In that area, more and more temperature is producing. As a result of it, nearby area has any burning or inflammable substances. If nearby any inflammable objects are there, substances are there, then fire occurring chance is there. So here high temperature is occurring, slow by slow you can find that fumes are occurring, then that particular time nearby any burning things are there. We can say that now suppose paper is there or clothes are there, dried clothes are there, such things all, or dried wood is there. These all things are nearby, then they will catch fire. So we can say that here as a result of it, so much fumes will occur, even fire occurring chance is there. As a result of it, nearby which all things are there, they all will catch fire. So we can say that this is known as short circuiting. Now earthing wire means our objects, we can say fridge, then AC, then TV, all these things are having a connection with the earth. So which all devices we are having, to them all having one kind of wire connection towards the earth. As a result of it, we are getting protection from shock. So for that, one earthing wire connection will be there in all devices. We can say that fridge, computer, even computer we can say. Then TV, AC, all these devices, they all are having connection to the earth. As a result of it, when we are using all these devices, we are not getting shock. Why? Because this earthing wire protecting us for from getting shock. Now, thank you.